In this video, we will look at some examples on parallel lines, skew lines, and intersecting lines. Example 1. Parallel lines. Show that the given lines are parallel. Well, in this question, we have to prove that the given two lines are parallel. We know that two lines are parallel if their direction vectors are parallel. So in order to show that the given two lines are parallel, we will show that their direction vectors are multiple of each other. So the direction vector of given lines are the direction vector of first line is, say, b vector equals to 3 minus 4 9, and the direction vector of second line, let us call it c vector equals to minus 6 8 minus 18. Now we have to show that the two direction vectors are multiple of each other. So in order to check whether the two vectors are multiple of each other or not, we just make the first component of two vectors same. So in order to make the first component minus 6 of c vector to 3, take minus 2 common from the c vector. So c vector becomes 3 minus 4 9, which is basically b vector. So we can write c vector equals to minus 2 times b vector, as c vector is a multiple of b vector, which means C and B are parallel vector, hence the lines are parallel. Example 2. In this example, we are given two lines, the vector equation of two lines, and first we have to show that the given lines intersect, and then we have to find the point of intersection of these lines. Now, the two lines, we know that in order to show that two lines intersect, we find a general point on the two lines, equate the like components to form three different equations, solve any two of those equations to get the values of the parameter. If that value of parameter satisfy the third equation, then we say that the two lines are intersecting. Okay, so let's start with the general point on the lines. So we are given two lines. General point on line 1 is, general point on line 1 is, let us call this P, point P, 16 minus 12 lambda minus 4 plus 4 lambda and minus 6 plus 3 lambda. Similarly, general point on line 2 is, let us call it point Q, 16 plus 8 mu, 28 plus 8 mu, and 15 plus 5 mu. Now equating the like components, by equating the like components, we get 16 minus 12 lambda is equal to 16 plus 8 mu, or we can write it minus 12 lambda is equal to 8 mu. Let us call it equation number 1. By equating the y component of both the equations, we get minus 4 plus 4 lambda equals to 28 plus 8 mu. This implies 4 lambda is equal to 8 mu plus 32. Called it equation number 2. And by equating the z components of points P and Q, we get minus 6 plus 3 lambda is equal to 15 plus 5 mu. And by simplification, we get 3 lambda is equal to 21 plus 5 mu. Now we solve any two of these equations and find the value of lambda and mu. Well, from equation 2, we can write 4 lambda is equal to 4 multiplied by 2 mu plus 8. Cancelling 4 on both sides, we get lambda is equal to 2 mu plus 8. Put it in equation 1. Put in equation 1, we get minus 12 into 2 mu plus 8 equals to 8 mu. Minus 24 mu minus 96 equals to 8 mu. By simplification, we get minus 96 equals to 32 mu, or minus 3 is equal to mu. Putting this value of mu in equation 1 to get the value of lambda. So we get now put mu is equal to minus 3 in equation 1. We get Now put mu is equal to minus 3 in equation 1. We get minus 12 lambda is equal to 8 into minus 3. Minus 12 lambda is equal to minus 24, or lambda is equal to 2. These are the values of lambda and mu. If these values satisfy the equation 3, then the lines will intersect. So in order to check whether the lines intersect, put lambda equal to 2 and mu is equal to minus 3 in equation 3. Equation 3 is 3 lambda is equal to 21 plus 5 mu. 3 lambda is equal to 21 plus 5 mu. So putting the value of lambda and mu in this equation, we get 3 into 2 is equal to 21 plus 5 into minus 3. 6 equals to 21 minus 15, or 6 equals to 6, which is true. So lines intersect. Next, to find point of intersection of these lines, put either value of lambda in point P or value of mu in point Q. So we put lambda is equal to 2 in P. We get P. The coordinates of point P was 16 minus 12 lambda. 16 minus 12 into 2. This is the x coordinate of the point of intersection. Minus 4 plus 4 lambda. Minus 4 plus 4 into 2 y coordinate of the point of intersection, and z coordinate is minus 6 plus 3 lambda, so minus 6 plus 3 into 2. So this is the required point of intersection. 16 minus 24 minus 4 plus 8 and minus 6 plus 6. So minus 8 4 0 is point of intersection. Next, example 3. Show that the lines with vector equations this and this do not intersect. In this example, basically we have to show that the given lines are skew lines. So in order to show that the two lines are skew lines, first we have to show that the given lines are non-parallel lines. And secondly, we will show that the given lines do not intersect. So first, we will show that the given lines are non-parallel lines. So in order to show that the lines are non-parallel lines, we show that their direction vectors are not parallel to each other. So direction vectors of given lines are, direction vector of line 1 is minus 2 1 3. Direction vector of line 2 is minus 6 1 4. We will show that the given vectors are not multiple of each other. So if we take 3 common from C vector, it can be written as -2, 1 over 3, 4 over 3, which is clearly not equal to B. This vector is not equals to B. So we can conclude that the given two lines are not parallel to each other. Direction vector of given lines are B vector and C vector are not multiple of each other, not multiple of each other. So given lines are not parallel. Okay, next we will show that the given lines do not intersect. So in order to show that the given lines do not intersect, general point on line 1 is, let us call it P 4 minus 2 lambda, 7 plus lambda, and 5 plus 3 lambda. And similarly, general point on line 2 is, say, point Q 1 minus 6 mu, 1 plus mu, and 10 plus 4 mu. So these are the general points on the line. Equating the like components, of both the points, we get the equations 4 minus 2 lambda is equal to 1 minus 6 mu, or we can write it minus 2 lambda is equal to minus 3 minus 6 mu. Called it equation 1. By equating the y components of 2 points, we get 7 plus lambda is equal to 1 plus mu, and this equation can be written as 1 lambda is equal to minus 6 plus mu, equation number 2. By equating the z components, we get 5 plus 3 lambda is equal to 10 plus 4 mu, which implies 3 lambda is equal to 5 plus 4 mu. Now we will solve any two equations to get the value of lambda and mu. Well, so using equation 2 in equation 1, we get minus 2 into minus 6 plus mu equals to minus 3 minus 6 mu. Multiplying minus 2 in the bracket, we get minus 2 times minus 6 is plus 12, minus 2 mu is equal to minus 3 minus 6 mu. Now simplifying, we get minus 2 mu plus 6 mu equals to minus 3 minus 12, or 4 mu is equal to minus 15. This implies mu is equal to minus 15 divided by 4. Put this value of mu in equation number 2 to get the value of lambda. Put in equation 2, we get lambda is equal to minus 6 minus 15 over 4 equals to minus 24 minus 15 divided by 4 equals to minus 39 divided by 4. So mu is equal to minus 15 over 4 and lambda is equal to minus 39 over 4. Now if these values of lambda and mu satisfy equation 3, then the lines will intersect. And if these values do not satisfy equation 3, then lines will not intersect. Put value of lambda and mu in equation 1. Sorry, in equation 3. We get 3 times lambda is minus 39 over 4 equals to 5 plus 4 times mu is minus 15 over 4. So we get minus 39 into 3, it becomes 117 divided by 4 equals to 5 minus 15. So minus 117 over 4 equals to minus 10, which is not true. So lines do not intersect. Hence the lines are skew lines. Hence lines are skew lines. That's it for this video. Thank you for watching. Hope to see you in next video.